Hello everyone, welcome to VMS class. In this video, I am going to explain how to train and evaluate the support vector regression model for predicting the salary. Okay, in this project, we predict the salary based on the position level using support vector machine. For this, I am going to use the dataset position salaries, which is available in the Kaggle. It's a very small and a simple data set to perform the training and evaluation of the support vector regression. So you can click on this download. I have already downloaded the data set. You can see this is the data set position underscore salaries, which contains three features. One is a position and a level and salary. So position is basically a categorical column and level is a numerical column. We can take level and position also as input features and salary as the target column. Okay. So for this, you can upload this dataset into the Google Collaboratory first. You can select the upload option and select this salaries dataset, which is the CSV file. The dataset contains position, level, salary. The target contains the salary column. And support vector regression is mainly useful to find the relationship between the input and output features when the data is non-linear. In the dataset, the salary increases slowly at lower levels and increases very fast at higher levels. So SVR can help us to learn this kind of non-linear salary patterns using the kernel functions. Coming to the execution process, first the cell which is available here for importing all the required Python libraries. So we use pandas for loading and handling the dataset, and we use a matplotlib for creating charts and visualizations, and we use numpy to generate some kind of numerical vectors, and to perform some kind of smoothing we are going to use numpy, and sklearn we are going to import the StandardScaler, which is useful for feature scaling. And finally, we are importing the evaluation metrics, mean absolute error, mean square error, and R2 square for evaluating the model. Then we are going to load the data set. Okay, let me clear all the outputs first. Now the data set is loaded using pd.read underscore CSV. This data set is stored in a data frame called df. Then we use df.head to display the first 5 records from the data set. Okay, then you can see the shape of the particular data set using the df.shape. So with this, you can see how many number of rows are there and how many columns are available in the data set. So we have 10 rows and 3 columns are there. So this data set is very small. So it is very useful for understanding SVR visually. Even you can use any bigger data set also in the same way. Then you can get the dataset information by using df.info method. So this gives the information about the column names, data types, and non-null values present in the dataset along with the memory usage. Okay, so this helps us to confirm the level and salary are numerical columns. You can see that the level and salary are numerical columns and position is the categorical column. Next, we can see the missing values using df.isNull.sum. Missing values can affect the model training. If all values are 0 for these columns, then the data set is clean. You can also display the statistical summary using df.describe so that you can get the statistical summary of the level and salary, such as the mean, count, standard deviation, minimum, maximum, and different kinds of percentage also you can get it. Now here I am going to display the complete data set here for checking how many total columns are there, because this is a simple data set. That's why I want to display all the rows and all the columns before going to the visualization. Okay, this helps us to clearly understand how salary is going to change the lower position levels to higher level position. If you see that the lower level position, level 1 is 45,000. We take level 8, it's approximately 3 lakh. If you take level 9, 5 lakh. It is take level 10, it's 10 lakh. So this kind of data, we can say it's a non-linear kind of data. Then visualize the level versus salary. So in this cell, we can create a scatter plot between the position level and salary. The x-axis is the position level here, and y-axis is containing the salary. Okay, from this graph, you can see that the linearity of the data. It's basically not a linear, it is non-linear. Okay, it shows that clearly a curve. If the position level is increasing, the salary is also increasing. But notice that it is not a straight line equation. Okay, the data is not in the form of a straight line. It is basically a curve kind of a pattern. Okay, salary is not increasing in a straight line here. At the lower levels, salary increases slowly, but when the level is increasing, the salary is increasing rapidly. So this is why the support vector regression is suitable for this kind of problems. Okay. Now select the input and output variables. I am taking X is a level feature and Y is the salary feature. So you can execute this step. Then after feature scaling is very important for support vector regression. So in this data set, the level values are small, but salary values are very large. So that's why we need to scale both input and output using the standard scaler. So here I have created the standard scaler for X and Y separately using creation of an object x underscore scalar y underscore scalar. Now x underscore scalar dot fit underscore transform of x, that is the x scaled data, and y scalar dot fit underscore transform, that is the y scaled data. Now you can train the SVR regression model. For this we can use the support vector regression function, as well as we are going to use the kernel function RBF here. RBF stands for the radial basis function. So this kernel helps us to learn the non-linear patterns. So I have created the model at this line and training this model at line number 5 in this cell. So I am passing x scaled and y scaled data ravel function here. So if the data is now two-dimensional, y-scaled ravel is going to give a single dimensional data. So then I am going to perform the training process in this cell. Okay. So now the training is completed. It tries to create a smooth curve that captures the salary pattern. Now predict the salary on the existing levels. On the X scaled data, I am going to predict it. Okay. Model dot predict of X scaled data. I'm just taking only how it is going to predict on the existing data itself. That's why I'm taking X scaled. Then I'm going to store that in the Y pred scaled. Now, basically, when you predict these results will be in the scaled format. So, if you want, you can inverse transform the scaled values. So, y scalar dot inverse transform, then y pred scaled dot reshape of minus 1 comma 1, so that you can get the inverse scale values of the salaries. So, these are the actual predictions here. Now compare actual and predicted salary. So in this cell, we are going to compare the actual salary and the predicted salary here. I am creating a data frame for that. So pt.data frame, the actual salary is the df of salary, okay, and predicted salary ypred dot flatten. Okay, if it is again two dimensional, then it is going to make it in a single, okay, row. So then that is I am going to display. So this is the actual salary and the predicted salary here. Okay. Now evaluate the model on the test data now. Okay. Now here I am going to take the actual salary, okay, along with the Y predictions. Okay. So DF of salary is the original column values, that is the actual salary, and Y pred is the predicted salary. So I am going to compute the mean absolute error, mean square error, and R2 square, and printing the results in MAE, MSE, and R2, and then I am printing the error values here. Okay. Now you can notice that R2 square is a 0.75, so which indicates that it is model is going to understand the 75% of the data. Okay, still we can even improve 25% more. So we can apply different kinds of optimization algorithms to improve this model. Then next we are going to visualize the SVR predictions, how these predictions are going to be. So for that, I am going to take the actual salary points and SVR predictions. So blue points represents basically the salary, and red points predicts the SVR predictions. If you see this graph here, so you can notice that how this curve is going to be moving here. Okay, this graphs helps us to see whether the model is following the salary pattern or not. You can see that the model is following the actual salary pattern here. Okay, so it means model is better. Okay, we cannot say that it is a best because R square is only 75%. Even still, we can improve the model. Then we can smooth the curve. Okay, this is one of the most important visualization cells. So if you draw the prediction line only on level 1 to 10, the curve may not look very smooth. So we generate many values between minimum and the maximum level. For example, instead of taking only 1, 2, 3, we generate values like 1.1, 1.2, 1.3, and so on. So then we scale these values using the same input scaler. Next, we predict the salaries using for the smoothed values. And finally, we convert the scaled predictions back to the original scaled values here. Okay, so this gives a smooth SVR regression curve. So what I am trying to do, so you can now see that I am going to take multiple values so that you can find the curve even in the better way compared to the previous curve. So now you can create a new data set, okay, and for testing, predicting the salary for new position level. Okay, here we predict the salary for a new position level. So I have taken that level is 6.5. Okay, so this is useful when we want to estimate the salary for an intermediate role. So before prediction, we must scale the data. Okay, here before prediction, we must scale the data. Then using the same scaler which we have used during the training. Then after prediction, the data will be in the scaled form. So what we have to do, we have to do the conversion. Okay, so we convert it back to the original salary using the inverse underscore transform. So this is basically the correct real-time prediction process in SVR. So then I am going to print the predicted salary here. So now you can see the predicted salary for level, which is 6.5. Okay. Now predict multiple salary values. Okay, if you want, you can also take multiple values. In the previous cell, I have taken just 6.5. Now I have added multiple levels here. So new levels. So the same thing, you are going to transform it, x underscore scalar dot transform of new levels. Now we got the scaled data. Now that scaled data will be given to the model for prediction. Now this is the predicted salaries underscore scale. Now this is basically the scaled data. Again, you are going to do the inverse transform. Okay, y scalar dot inverse transform of this scaled data dot reshape of -1 to -1. Basically, this cell and previous cell both are same, but in the previous cell we have taken only a single level, but here we have taken multiple values for prediction. Okay, like this, you can see that. And the same thing, I am going to display a plot, okay, which is actual versus predicted salary. Okay, so this graph basically compares the actual salary and predicted salary. So here again, blue points represents the actual salary and red point represents the predicted salary. So now if you print that, you can see the actual values and predicted values. Okay, so this gives us a simple visual comparison of model performance. The blue points are the actual values, red points are the predicted values. You can notice that. So these values are very near together, okay, except to the last level, okay, last level. So the remaining all values are predicting better, okay. So coming to the final insights, what we have discussed in this, here, support vector regression can handle non-linear salary growth. SVR uses the kernels to learn the complex patterns, like we have used RBF in this example. So feature scaling is very important for SVR because if you take the level and salary are having different ranges. So levels are having very low range like 1 to 10, then salary is having a bigger values. So that's why scaling is very important here. So RBF kernel, which helps to create a smooth regression curve. And SVR is useful when the data does not follow a straight line relationship. And this SVR can be used in multiple applications like salary prediction, financial forecasting, stock price prediction, demand forecasting, energy consumption prediction. Multiple applications, we are going to use this SVR regression for predicting the numerical values. Okay, so please try to practice this example. I have taken a very simple data set which is useful for understanding this kind of visual patterns. If you take a very big data set, so the understanding is difficult. So if you have very less data set, you can clearly see how the data pattern is there, how the predictions are there. Everything you can easily understand. Now, even you can take any bigger data set. So that is not a problem. You can just split it into the input features and output feature. Then you can perform the model training by considering the scaling before performing the model training and testing process. Okay. Thank you. If you like this video, please subscribe to our channel for getting more updates on computer educations. I will see you in the next video.